So hai, hari ni saya akan membentangkan tentang final year project kami iaitu Innovation of Concrete using Shell of Pila Ampullacea. Projek ini untuk kos BCC 50194 iaitu Civil Engineering Project 2. Supervisor kami iaitu Encik Muhammad Salih bin Abdullah. Komplain kami terdiri daripada saya, Putih Setiap binti Kamal Zaman, dan nombor kad meter saya 17 DKA 20F2055 dan partner saya Muhammad Al-Ashraf bin Aziz 17 DKA 20F2059. Seterusnya konten kami terdiri daripada introduction, background, problem statement, objective of project, scope of project, metodologi antaranya adalah flowchart, terdapat juga design ratio, cost estimate, literature review dan
Design thinking process, stage 1 empathy, design thinking process, stage 2 define, design thinking process, stage 3 idea, data analysis, introduction, compressive strength test, 7 day and 28 days, calculation of design mix, cement, sand, cost, aggregate, water, chapter 1, 2, 3 and 4, conclusion and reference. Introduction.
So sekarang saya akan terangkan tentang introduction. Kita tahu development of structure sekarang terhimpit dengan kekurangan sumber menjadi pasir dan simen. Bagi kita tahu dua primary ingredient dalam konkrit ialah pasir dan simen. So projek ini untuk mencari new effective environmentally friendly replacement of substitute of sand. Tujuan kami untuk modern concrete infrastructure frequently reinforced with concrete that have been mixed in various reaction untuk dapatkan greater mechanical strength and a longer shelf life dan improvement of the quality of the concrete. So, projek kali ini kita menggunakan kulit cekaram Pila Ampullacea yang kering. Ini karakteristik yang sama dengan she cell yang menjadi substitute particle of fine aggregate in concrete. Visual research have been done and some study that show replacement of fine aggregate in concrete, but mereka menggunakan she cell in dalam innovative concrete mereka. So kelainan projek kami menggunakan snail shell of Pila Ampullacea yang murah dan kurang demand dalam industri pembinaan yang mana boleh digunakan sebagai substitute of sand dalam kaedah yang baru.
Background of the project. The current sand stock is decreasing with the demand for vaccine that require glass bottle made of sand varying construction company because 50% of sand is in this industry. Alternative materials for sand in concrete mix are urgently needed to avoid full exploitation of the sand market with diminishing sources. Pila Ampullacea has strong skin and suitable for use as an alternative to sand in concrete mix. According to Chakrabarti, SGM Mustafati, she-cell are suitable as substitute for aggregate in concrete mixing. Problem statement. Based on the graph, you can see the demand of sand drastically increase. Sand is a limited and non-renewable resources, may run out if we are not kept from using it. New resources need to be found to be an alternative. Pila Ampullacea can be the substitute sources as an additive reduce sand demand. The construction industry is one of the most demanding for sand. The construction industry alone uses 50 billion tons of sand a year.
For the objective of project is to determine the mechanical properties and the physical properties of the shell of Pila Ampullacea. Seterusnya to analyze the behavior of Pila Ampullacea through slam test and compression strength test. To compare the strength between the original mix of concrete and the sample of concrete with Pila Ampullacea with a 5, 10, 15 and 20%. Untuk scope of project, the scope of project is based from objective can be simplified as follows. Investigate the result of previous concrete made from waste, prepare the aggregate, cement and shell of Pila Ampullacea, mixing the design calculation following the void ratio, lastly to compressive strength and slam test.
The methodology. This method statement outlines the procedure to follow while installing, curing, and fixing flaws in concrete work and blind concrete. All quality inspections must be finished and permission to concrete construction must be given by the client or consultant or prior to placing any concrete or performing any concrete works.
So for the flowchart, firstly what we need to do is to identify the problem. So the problem is the hampered of the shortage of sand. So we industrial by the product, which is for Pila Ampullacea. Then we crushing and grinding the dry shell of Pila Ampullacea, and we do a physical and chemical characteristic of replacement of Pila Ampullacea. Then we do the mix proportion. We use 5, 10, 15 and 20 percentage. Then we do it mechanical properties by compression, strength test and slam test. Then we waiting for 7 and 28 days. Then we do the data analysis. If it's good data analysis, we can proceed it to the conclusion. If it's not, we need to back to mix proportion and we need to repeat clinical properties with the compression and slam test. For design ratio, we use 1 for cement and 2 for sand and 4 for the cost aggregate. So we use 1, 2 and 4. 1/2 and ratio of 4. So we have a full sample here, excluding the control sample. Control sample we use the 0 of the set of plus. Yeah. For the sample 1 we use 5%. For sample 2 we use 10%, and for the sample 3 we use 15%, and for the sample 4 we use 20%. So the change of the ratio is, we can see it's at the same. So the sample it will be less because of we substitute or replace the sand in the concrete with the percentage of Pila Ampullacea. For the cost estimate, we estimate it for the one batch is around 61 ringgit 70 cent, which is for the cement we use the ordinary Portland cement. The unit for one batch around 60 ringgit 17 cent, and for the sand have been saved, we use around 35 ringgit per 1 kilo. For the cost aggregate around 10 ringgit around 5 kilogram. The Pila is price, which is we just take it from lake or from the rice plant.
This is literature review. There are some journals from various places for other people to start our research based on seashell or any smell that make an alternative for any concrete mixings. This is other journal that we get about seashell. From our reading, we get that seashell is strong and suitable for our research. Design thinking process stage 1. First, empathy. The effect is to farmer and construction company. The problem is for farmer, rice crops are distributed due to parasites such as Pila Ampullacea. Need systematic control over the population of Pila Ampullacea. And for the construction company, use of sensors or construction company. And the next construction company are looking for a suitable material as an alternative to sand in the concrete mix. Design thinking process stage 2. Define. This is our resources from journal, from website and from YouTube for our study to get more information. Design thinking process testing. Pila Ampullacea shell as an alternative for sand in concrete mix. Snail skin is proven to be alternative material in concrete mix based on previous studies on clam and seashell. Pila Ampullacea wood reproduction is uncontrolled and usually found in rice field was chosen as a substitute for sand in the concrete mix.
For the data analysis, the introduction is the main objective of this experiment is to find out the difference and the effect of the strength of the concrete mixed with the replacement of fine ingredient in this mixture. And the five different percentage of fine ingredient which replaced in this project, which is 0, 5, 10, 15, and 20 percentage. The data we collected from the laboratory test and it was done based on the data analysis and the result. To meet the goal of this study, all the data gathered in order to conduct analysis and draw the conclusion about all type of testing in addition. We will use the compression strength test, which is a concrete sample will substitute with the fine aggregate of Pila Ampullacea with 5, 10, 15, and 20% from it will made in order to evaluate the difference of inequalities. The cube that we use is measuring 150 millimeter divide by 150 milliliter and divide by 150 millimeter. So the next slide will show the result of the compression strength of the cube sample of 0, 5, 10, 15, and 20% of replacement of fine aggregate with the recycle of Pila Ampullacea cell shell in the concrete mix for 7 and 28 days. So this is a calculation for design mix. So we use 6 cube for one batch, which is the size of cube is 100 millimeter. For the cement, the design liter is 1, which is the weight of one batch is around 6.25 kg. For sand, we use 2 for the ratio, and the weight of one batch is around 12.81 kg. And for the coarse aggregate, we use 4 ratio, which is for one batch is around 28.54 kg. For the water is 0.7 weight of cement, which is 0.7 divided by 6.25 kg. For the water is around 4.374 kg or liter. So this is a calculation for design mix. So we use 6 cube for one batch, which is the size of cube is 100 millimeter. For the cement, the design liter is 1, which is the weight of one batch is around 6.25 kg. For sand, we use 2 for the ratio, and the weight of one batch is around 12.81 kg. And for the coarse aggregate, we use 4 ratio, which is for one batch is around 28.54 kg. For the water is 0.7 weight of cement, which is 0.7 divided by 6.25 kg. For the water is around 4.374 kg or liter. This is the slide for the compressive strength test for the 7 days. We can see here the average of MPA for 0% is 15, and it get lowest when it replaced with 5% is 7.85, and for the 10% it's 8 MPA. For the 15% is 8.37, and for the 20% is 8.50. So this is the 28 days of compression strength test. So we can see in average of 10% is 20, and it get lowest for 5%, which is 5%, which is 12.82. For 10 is 7.98. For the 50 is 6.98. For 20% is 6.92 MPA. So this is the graph for the compression strength test. For the axis Y, you can see is the percentage, and for the axis X is the average of MPA. So we can see there is a 5 graph out there. We can see the outcome of the result of the compression strength test is not suitable from the control sample.
Slump test. Sample and result that we get is all collect slumps. We begin with our sample with 5% of Ampullacea. The slump is 11 centimeter, and for 10% sample is 10 centimeter, and then 15% is 7 centimeter, and 20% is 6 centimeter. That's all result is a collect slump and not suitable for our regular use. Conclusion. As conclusion, our study to innovate the use of snail shell Pila Ampullacea in concrete was not successful because the compression test and slump test shows that this concrete mixture was far below the standard in the market. This is few of our reference that we get the information. Thank you. That's all from me, Muhammad Ashraf bin Aziz. And thank you for hear what I said.